Yeah, following the two successful programs of Senior Talk, first one by Samir Mehta on the relevance of MBA, and the second one by Karthik on ERP and SAP. And today we are getting connected with one of our another esteemed alumni, Dhruv Chopra. So Dhruv Chopra is 2006 pass out student from our Sairam College of Engineering, then College to Design Engineering College. And to my knowledge, like he was my student, so I had joined my profession by then, and he is very for my observation, he's a very studious and brilliant chap. And yeah, that's a fact, though we cannot deny. And he is very very active and very participative in almost all the events and activities which has been conducted at this part during that time of his college time. And the things I remember about him, like if I'm right, like he has done image processing based project work during his final year on palm scanning, right? Even before the emerge of this biometric was there, but it was not completely in practice or in use in India at that time. So without biometric device, just by using a normal scanner, the regular document scanner what we are using, he had read the palm, and using image processing, he has identified the identity of the person using that technology. Am I right, Drew?
Yeah, that's right. That's right.
Yeah, that was his project work, and I think he got a lot of recognition and appreciation for that project. And not just that, he was a bright student, as I said. And during then, the campus interviews used to happen for all the students during the pre-final year and not during the final year. So after sometime it was the NASCOM regulation not to visit the campus during pre-final year, and the campus interview started happening only for final year students. But during his batch, it was during the third year or the end of fifth semester, the students used to appear for campus interviews. So at that time, he was placed in a company during his pre-final year in Character. Right. By then, the company was called as Character. Character was, I think, that was the first time we had bought Character on board. And this was the first batch to face that interview. And many students were successfully placed, and he is one among. And I was very excited and glad to see when I saw his LinkedIn or his profile, what he has forwarded, that he has served the same organization for 11 years. Like after getting placed in Character, the company had changed his name twice or thrice. Like it became Keen in between. Then it became right now it is called as entity data. It is recognized as entity data. So Character became Keen and Keen became entity data, but Dhruv Chopra was still serving the organization. That was very glad news to see. And for the students, like all these days we have listened to a lot of experts and a lot of resource persons talking about all this emerging technology like big data, artificial intelligence, 3D printing. And you might have listened to a lot of lecturings and videos, some materials from the resource person who are directly not working. Like even the resource person, whoever is delivering, be it your faculty or any other resource person, whoever has come on board as of now, they are the person who have read something and who have only theoretical knowledge about big data or artificial intelligence. Whatever they have seen, they have communicated to you. But today's resource person, Dhruv, is someone who is working with the technology for the past few years and who has solved many critical problems using those artificial intelligence and machine learning. So when I had an informal discussion with him to bring him on board for this program, then when he said, can I do something on artificial intelligence and machine learning, which is my course, I was more than overwhelmed, and I was very glad to immediately accept the title and fix up this program today. So I think we have very limited time to listen from a resource person. I think the time should be around 9:30 there, Dhruv.
Yeah.
Because of this timeline difference, we could not schedule this program in the morning hours. So we have kept it because it's already just 9:30 a.m. for that. If we had to schedule it in the morning, then it would have been even more earlier for him. So for the convenience of this time zone difference, we had fixed this program by afternoon. So this is a short memory or a brief introduction about Dhruv. Probably principal will be giving his career, achievements and other related information during his welcome address. So I'm very, very, very glad to welcome Dhruv Chopra on board for this third session of Senior Talks. Hope the session will go in a very informal way, as I say every time, and it should be very interactive. I request all the students this is one great opportunity for you to interact with someone who is directly working with artificial intelligence and machine learning. You can get to know a lot from him, and I am also very eager and keen to listen, know so much information from him. With these few words, I would like to request our beloved principal, Dr. B. Sarakshara Prasad, to render the welcome note and give a brief introduction, professional introduction about the guest. Thank you.
Thank you.
And also say hi to all the other invitees and Karthik, the previous session resource person who was also joined as guest today. And there are so many other alumnus and other faculty and resource persons from our group of institutions are also there. A big hi to everyone. And with this note, I request principal to take this forward. Thank you.
Thank you, Arun sir. Thank you. Respected dignitaries, good afternoon to all of you. Our management representative, Dr. R. Arun Kumar, our trustee, Patel sir, and today's guests, our speaker, our proud alumni, Mr. Dhruv Chopra, and our other alumni, they joined today. Karthik, I welcome you. Tejas, Nirmala, and the secretary of this alumni association, Dr. Hari Krishna, and students of our own college, and the students from Chennai Sairam Engineering College. They also joined today. And also I would like to welcome our vendor, Shiva Universes, to this particular webinar, Senior Talks, Small Talks, Big Lessons. And today we are hosting this talk on emerging area, artificial intelligence and machine learning in real world. This is order of the day because I request all my students to make use of this particular program very effectively. This session is from live from Coventry, UK. I request everybody to make use of this. And I once again I welcome all of you on behalf of Sairam family to this webinar. Please, and now I'm taking the opportunity to introduce our proud alumni, Mr. Dhruv Chopra, to this August gathering. Dhruv Chopra, Senior Developer, KBBS System, United Kingdom. He is our alumnus, passed out in the year 2006 from Electronics and Communication Engineering. Dhruva placed through campus interview in entity data during his third year engineering as a fresher, completed 11 plus years and became senior technology manager. Past 2 years, he is working at KBBS system in UK, developing insurance fraud detection software using artificial intelligence. He worked in technologically challenging fields like dosimetry, that is a nuclear radiation detection, and dose calculations. He worked in deployment of machine learning to predict hardware failures in super used data centers. He extensively handled different international clients from countries like US, UK, Germany, Australia, Japan, etc. So this is about our proud alumni, Dhruv Chopra. I welcome you, Dhruv Chopra, to this webinar on behalf of our entire Sairam family. And at the same time, I would like to tell to our students that I request everybody to actively participate in this session because this is an emerging area. Please make use of this session effectively by interacting with because he's your senior, though he's a guest over this particular session, but he's your senior. You can please feel free to interact with him for any clarification, and also you can chat the questions so that we'll take up that questions at the end. Please make use of this program effectively, and I wish you all the best. And now I swore to Dhruva to continue the session. Thank you.
Thank you so much. Thank you for the welcome. I hope everybody is able to hear me clearly. Right. Let me just share my screen now. Should we start?
Yeah, please.
All right, I'm sharing my screen. Oh, there are a lot of controls. Let me minimize this. Right. So, one minute before we start. Good morning, good afternoon, sorry, and thank you for the great welcome. Really appreciate it. Also appreciate the fact that Arun remembered what project we did. I was not expecting that, so good on you, Arun, for remembering that. Really happy about that. I'm not sure why Microsoft is trying to update in the middle of a demo, but that's how things are these days. Anyway, so today's talk. So today's talk will be on AI and ML in the real world. I've actually had the good fortune of working in multiple implementations. And because of this, I've been able to see some things that are common across implementations. I'm also able to see what the future trends are most likely going to be. And amongst all of this, I will try to keep it simple because AI and ML can get convoluted and difficult to follow very fast. And I understand that our audience spectrum this afternoon is quite wide. So I'll try to keep it as simple as I possibly can. Right. So before we start, let's set some context, right? In today's world, I mean, no matter how old you are or how young you are, you have WhatsApp. And I have seen old grandfathers who would really hesitate from going near a computer, but they have WhatsApp on their phones and they know how to use WhatsApp. And our parents, of course, they use WhatsApp. And we use WhatsApp not only for, say, entertainment, but we also use it for work. And we do quite a lot of work through WhatsApp, right? Organizing meetings and taking status and so on and so forth. And WhatsApp is a third generation app. Now, what do I mean when I say it's a third generation app, right? So the first generation apps were made by the Narayan Murthis of the world. Now, they took something that was paper-based, banks. I remember when I was a kid, my parents used to have a passbook and the clerk in the bank used to make a debit entry, a credit entry. It was really paper-based. And then they took all of this paper-based world and they made it electronic, right? So that was the first generation of applications. The second generation of applications were made by people like me. We took everything online. Like everything is online these days. I remember when I was in college, if we had to book a train ticket, you had to go to something called the reservation office or a railway station, stand in line for a few hours and then book your ticket. It wasn't very common or I think even possible to book tickets online. But today it would be hard to imagine a world where you don't book a ticket online. Everything these days that we do is online. Next is what your generation will do, right? And you will take everything into the AI ML world. I mean, if you look around yourselves as to what AI ML is doing right now, in your personal experiences at least, it's not doing a lot. It might be doing a lot academically, but not in what we experience personally, right? So there is still a lot of work to be done. And truth be told, when I got out of engineering, it really didn't matter from which sort of stream people were in. Quite a few, or I would say most, somehow ended up in IT. I'm from electronics, right? So I'm not from CS, I'm from electronics and I ended up in IT. I know a lot of my friends from mechanical, electrical who ended up in IT. I feel something similar like that might happen with this because the opportunities here are tremendous. There is a lot of work to be done, a lot of work to be done. So it's not impossible to imagine that a lot of people would be needed to get AI and ML into everything that we need. Right. Now, as I was preparing for this presentation, sorry, I went through the VTU syllabus. The good news is that I was able to see that AI and ML are subjects, which is very good. And I skimmed through the syllabus. I didn't read it in any detail, but I did notice that there was some algorithm coding that was needed in a lab, which is very good. And when I noticed that, I was reminded of a experience that I had. So when I was doing ECE, we had a CS elective, and as part of the CS elective, we had some lab where we had to do these various sort of sortings: insertion sort, bubble sort, quick sort. And while it wasn't a very difficult lab, it wasn't a simple lab either. Mostly we were always confused because all the programs looked very similar. But eventually when we came out of engineering, we felt a sense of confidence that we knew the sorting algorithms because they were a bit tricky, right? And then we got into the real world. And what I realized in the real world was that nobody wanted me to sort. Nobody cared if I knew a sorting algorithm or not. And there were very good reasons for that. First and foremost, all the languages, right? C#, Java, Python, Ruby, they all had implemented sort in them. So I didn't need to code a sort because the implementation was already there. And second, and more importantly, the sort implementation in these languages was highly tuned, was really high performance. And if I were to try and implement the same thing, I would really be wasting the project's time, right? So that is why doing sort was like not needed. And this is the first time I felt that there was a disconnect between, say, the academic world and the real world. And that was like an eye-opener for me. And that's when I kind of decided, when I saw the algorithm scope in the syllabus, that maybe what I'll try to do is I'll try to bridge what is being done in the real world, so that when you get out there, you have a fairly good idea of what is being done and what may be expected of you. Right. So let's jump into it. Now we are going to do a thought experiment today. Just a minute. There are 3 notifications. I'm just going to see. Okay, that chat. I'm just checking. All right. Nothing important, I think.
Dhruv, no problem. We can handle all these notifications. Just go ahead with your slide.
All right, sure.
I and Mr. Reggie are the co-hosts, so we will handle all these notifications.
Okay.
If there is anything to be prompted, I'll interrupt.
All right, sure. Thank you. No worries. Yeah. All right. So let's do a thought experiment today. Now, some of you might ask, what is a thought experiment? A thought experiment is like a lab experiment, but it is run in the mind, and it's very scientific. It has entry criteria, it has exit criteria, it has benchmarks. And once you get into AI ML, right, you will be doing a lot of these thought experiments. And from my experience, while being in college, I think one of the best parts of college were the labs, right? They were really interesting. So let's do an experiment. And I think this will bring out the real world problem more effectively also. Right? Before we start, if someone is wondering, are the algorithms already available? Are they already tuned? The answer is yes. But I will also say that that's really where the easy part stops. And then you have the real world problem that follows, right? So what's our experiment? Now, our experiment is simple. I am going to tell my smart speaker. Now, smart speaker could be Google Voice, Amazon Alexa, Siri. We all have these sort of things on our phone these days. Some even have speakers at home. I have so many that I can't count anymore. So our experiment is going to be this: buy me a ticket to New Delhi. That's it, just 7 words. I'm going to ask my speaker, buy me a ticket to New Delhi, right? Now, assume I said this to a human friend. if I were to say this to a friend of mine and assume I'm in Bangalore right now, not in Coventry, then my friend would know intrinsically and without much thought that the only way I can go from Bangalore to Delhi is by a train or a plane. And he would also know, because he's a friend of mine, that I prefer train. And he would most likely immediately do a Google search for train tickets from Bangalore to Delhi. And he would be able to present, or not present, tell me what the most reasonable tickets are and what the best times are. And this is something that would be very trivial or simple for him to do. And this is going to be a benchmark in our experiment. So it's an experiment. So in the experiment, we need our benchmark, right? So this is going to be a benchmark that my human friend was able to do this fairly easily, right? If I'm being a bit fast, or if you're not able to follow, and if you need me to slow down, please inform Arun and Reggie sir, and I'll be more than happy to slow down and repeat. Maybe we can take a poll now, Reggie sir and Arun. Right, I'm just going to maybe wait.
No, you can just carry on. Reggie said you can throw the poll. It's in progress.
All right, good. So it looks like people are able to follow me. That's very good to know. Some are not. I will try to simplify if needed. All right, let's go. Having said that, so while I was a student, so Arun gave me a very flowery sort of introduction, but I was quite troublesome also in college. And Arun knows that I would have been one of those people who would have pressed the no button for the sake of pressing the no button. So don't worry about the no button. Right. Right. Let's continue. Now, slow down. Thanks. All right. 1 minute. Repeat. Looks like this poll is interfering. Where was I? Right. So now let's break this down from the point of view of a smart speaker. Now, the smart speaker would need to know that I'm in Bangalore. But really knowing that I'm in Bangalore, you don't need AI/ML. It can just get it from the GPS or from the IP address. So that's pretty easily sorted as far as the smart speaker is concerned. But it needs to use its intelligence to figure out the modes of transportation. Now, if you look at the slide, you can see that I've put in train, I've put in plane, I've also put in walking, and I've also put in car. And you might think, why have I put in train and car? I mean, car and walking, because they are not obvious choices, right? But the reality of today is that if you go to Google Maps today and say, find me a route from Delhi to Bangalore, it will give you walking instructions. It will tell you that it is 408 hours and that it is a 2000 kilometer walk. Now, that is a bit dumb, right? That is not intelligent. Obviously, we would not like to walk from Bangalore to Hyderabad. But the reason Google Map does this is because it's been programmed to show you several modes. And one of the modes is the walking mode. And our smart speaker will have to use this foundation to progress on, right? So that is why those 4 modes are needed. Now, this is actually a problem of classification. Our smart speaker needs to classify what are the acceptable modes. And in this case, the acceptable modes are rail and play. So say it runs an algorithm and figures out that it is these 2 modes, then that is one task done, right? So one step done from our smart speaker's point of view. Now, if the smart speaker has been with me for a while, it would have trained itself using something called unsupervised learning. And it will know that between the modes, I prefer train. So train is my preferred mode. So this is a second level of classification. In the first level of classification, we found the preferred modes. And in the second level of classification, through training based on unsupervised data, we found the preferred mode, right? Then once it's figured out the mode, it just needs to make a call to the IRCTC API, and it would get back a list of rates and times. Again, no AI ML needed here. Apps communicate with other apps on the internet using APIs all the time, right? But then see, there is another reality. Now, every year, the price of the ticket increases. Now, say it increases by 50 rupees every year. So last year, it was 750 rupees. As a human, I would know and I would predict quite rightly that this year it's most likely going to be 800 rupees. Now, say in the list, I got back several 800s, but then I got back 550 also. Now, as a human, and because the human being is our benchmark in this experiment, as a human, when I see several of the tickets at 800 rupees, I would feel, yeah, that's about right, because that is what I had mentally predicted in my head. So that's good. And then when I see the 550 rupee ticket, I would be interested, because that's something that I was not expecting. And I would be interested to know why that ticket is 550 rupees, right? Now, as far as a smart speaker is concerned, that is two problems. One, for it to be able to forecast the future price. Previously, the price was 700, then 750. Now it expects it to be 800. That is called a regression problem. So that is mathematical regression. And when it detects 550, it needs to flag it, right? That's of interest to us. That in the machine learning world is called anomaly detection. It should be able to detect anomalies. Now, let's go back to our human friend. He's going to look at the 550 rupees ticket first, but he realizes that it's for 1 o'clock in the morning. So we're going to ignore it, because nobody likes to be disturbed at that early in the morning. And then from amongst the 800 rupee tickets, he's obviously going to choose the best time for me and let me know which one works best, right? And that from a smart speaker point of view is basically two more classifications. One, it needs to classify if our anomaly is worth using or not. And second, it needs to classify the best available time slot to tell me. And this ends our experiment. So at this point, I hope people are getting an idea of how even simple actions that we have in the real world tend to be quite laborious in the AI and ML world, right? Now, in addition to this, there are some more real world problems. But before I get there, let's put this in a state diagram so that everybody kind of understands where we are at. We said we will do a first level classification, calling it C1, to find our acceptable modes. Then we will do a second level classification to find our preferred modes. Then we will do a mathematical regression to kind of predict what the price should be. Then we will do an anomaly detection. So generally, when you do a regression, you have to do an anomaly detection also, because I mean, IRCTC API could be wrong, or it could be sending you back garbage results, or there could be a real anomaly. So these two go hand in hand most of the times. Then we would do an anomaly detection. Then we would do a classification of the anomaly, and then a classification of the best time. And I can tell you from experience that systems which do an anomaly detection, a classification of an anomaly detection well, are the really good AI/ML systems. It's very difficult to classify an anomaly in the real world, right? So I hope everybody's been able to follow the state diagram so far. And maybe we can have another poll at this point if people are able to comprehend what I'm saying, right? Right. So I'll continue. Now, there are other problems. The other problems in the real world are that the algorithm needs to be fast at each step. Nobody likes waiting. We have to run 6 algorithms. They have to run pretty fast. Second, of course, the results of the algorithm need to be good. Now, say if in the first classification that we did, if one of the acceptable modes that it found was walking, then that's not a good result at the end of the first classification, right? And because at the end of the first classification itself, we got a bad result, then everything downstream, sorry, I was having a sip of tea. Everything downstream would be significantly worse. So the results of the algorithm need to be good. And by themselves, having fast algorithms is a difficult problem. Getting good results is a difficult problem. When you marry both of them, it is a far more complex problem than these two problems by themselves. So I'm going to digress a bit here. When I was in college, computer science mathematics used to be a very binary sort of mathematics. You would do AND or XOR. If you were trying to be very intelligent and smart, you would do the Karnaugh maps. I could never get my head around that. But ML algorithms, right? They rely on regular mathematics, which is very complex. And take it as a tip from me. Keep interested in mathematics and learn the maths. Maths is very important in AI ML. AI and ML is the meeting point of fancy mathematics with fancy computer science. So far, for my generation at least, just doing fancy computer science was more than enough. But going forward, you will need to do both to make systems, right? So keep that in mind. Do your maths. And I'll stress on this again because I think it's very important. Now let's get back to our real world problem. Now, I've again drawn the state diagram here, C1, C2, R, AD, C3, C4. But if you think about it, as I went through my experiment, right? I was the one, Dhruv was the one who said, okay, I will do a first level of classification. Then I will do a second level of classification. Then I will do a regression. It was being decided by me. It was not being decided by the system. So the decision to do the classifications, the regressions, the anomaly detections were being done by me, not by the system. Those were my steps in the experiment. Now jumping from one step to the other step is called the action selection problem in AI ML. And really, we don't have, 1 minute, the poll seems to keep coming for me. We really don't seem to have solved the action selection problem in the real world right now. Right now, the action selections need to be coded in. The algorithms for action selection have been around from the 1990s, but no good real world implementation. In fact, I'll use the next couple of slides to kind of elaborate on the action selection problem. So airplanes have had autopilots in them for decades, right? So they've had it from the 1980s. And when airplanes have had autopilot, nobody's called it AI. And the reason they never called it AI was because really what it was a lot of sensor data feeding into some complex program, and the complex program would make reasonable decisions to fly the plane automatically. These days, of course, we have autopilot in Tesla. Tesla has been around for a few years, but they call the autopilot in Tesla AI. But what's really happening there is that the sensor data has gotten very intelligent. It makes use of neural networks in image processing to kind of determine how far the objects are and whether they are in hitting distance or not. But the complex program itself has not gotten smarter. So what's happening really these days is that sensor data has gotten smarter, but the program itself hasn't. And that's really because we are not able to do action selection in a reasonably efficient manner, right? So now let's look at the results of our experiment, because every experiment needs results. Now, one of the first results that we can maybe draw from this are that actions that are very trivial and simple for humans. For example, my friend to just immediately Google up and find me the relevant train tickets are quite long and drawn out in the AI and ML world. Second result that we get is that AI and ML right now work well on specific problems. But when it comes to the common sense things, action selection, it's really not up to the mark right now. And this actually gives us a good result, because if you were to ask a smart speaker today, right, buy me a ticket to New Delhi, it can't do that. You can't ask Google Voice, or you can't ask Siri, or you can't ask Alexa to buy you a ticket to New Delhi, right? Now, in the Alexa world, you have apps that they call skills. And there are a couple of them where you can buy a ticket, but they're very specific to the mode. They're very specific to the airline. And 95% of those will only give you a flight status. They will not allow you to buy a ticket. And you definitely cannot tell like Google Voice or Siri to buy you a ticket, right? So in that sense, we've gotten a good result from our experiment. So an experiment has to give you a conclusive result. And that's the sort of result we've got from this experiment. Now, hopefully, people are still with me, and they haven't kind of gotten bored or haven't withered away. So let's move on. So there are a few more things. Now, I briefly touched upon Alexa or the smart speaker training itself from unsupervised data. Now, training, collection, and cleansing has become a science in itself. A few years back when I started, we used to filter out words like the, and, because realistically, if I present you a statement where I've removed out these words and just have the important words, as a human, you will still be able to get some meaning out of the statement. But really, that doesn't fly anymore these days. You need these words to gauge the sentiment, because languages are complex. And depending upon the sentiment, the meaning might be a bit different, right? So sentiment analysis is becoming very, very important these days, especially when you want to get good results. And so far in my experience, at least, right, the use cases for AI and ML have been very English-based. And they've all been centered around English US. To give you an example, when Siri first came out, it came out for English US, English UK. It took them 3 or 4 years for it to come out for English India. Now, English is not the only language in the world. There is Kannada, there is Tamil, there is Hindi. AI hasn't made its way into these languages effectively yet. So there is like a lot of work to be done in this field right now. And on another point, I know when students get into AI and ML for the first time, they're most likely going to be introduced to reinforced learning. I'm not a very big fan of that because in the real world, it is far too inefficient. I mean, you can't keep crashing a Tesla for it to learn the right path, right? And it only really benefits the cloud providers, because when you do reinforced learning, you need a lot of compute cycles. So I'm not going into the details, but all I'm trying to say is, if you ever come across reinforced learning, do it. But in the real world, it's not as helpful as, say, classification, regression, anomaly detection are. right? And I'm going to mention a few algorithms here. Now, I know that in speaking with people in the field, these algorithms that I've mentioned out here are not very common in the literature. I am not sure why, but I can tell you from my experience that these algorithms have worked very effectively for me and at scale. And when it comes to classification, right, you would want to do a CW, confidence weighted learning, or a passive aggressive, or the arrow family adaptive regularization of weight vectors, or NHERD. And the screenshot out here is actually from the CW weighted algorithm. So you can see this is only one part of the paper. So the paper, I think, is 16, 17 pages. This is just a small section, and you can see that the mathematics is very complex. So again, I'm repeating, keep doing the math. This is classical mathematics, where you have something to the power of something to the square root of something. And believe me, when I was a computer science student, we only did 2 to the power of 32 or 2 to the power of 96. We really went away from this world. So keep going with the maths. For regression, Euclidean LSH, for anomaly detection, local outlier factor. And to be honest, I myself find the math very difficult to do. I wish I had spent more time doing the maths, and quite a bit of what I'm doing these days is just Googling and guesstimating because the math is so complicated. So I can't emphasize enough, spend a good time, take your maths seriously, right? A couple of things on learning also. Now, as a student, we are very used to learning, right? So class 1 to 12, we are learning something new every year. Then every year we get into a new year, and we have 2 semesters in a year. So our minds are tuned to learning everything every year. But when you get into work, after 1 or 2 years, right, the rate of learning reduces. But a real need is also that after about the 4th or 5th year, you need to generally learn again. But generally what happens is that after the 2nd year, because your learning drops off, then you might not really learn as thoroughly at the 4th or at the 5th year mark. You need, from my experience, I'm telling you, be a bit careful of that. It is very easy to get out of the learning cycle. So be mindful, especially in the AI and ML world. It needs dedicated learning. Now, if you go to the AI and ML world right now, you'll find a lot of progress. But really, that's just a bunch of abstracted tools over core mathematics. The core mathematics is moving quite slowly. So the need to learn in AI and ML is not as immediate as it might seem to you if you were to Google search for AI and ML. Once you know about it, then you know quite a bit. And algorithms take time to develop and take time to tune, right? So things are a bit slow there. But you need to keep going at it. And to finally conclude, right? So I'm hoping this has given you an insight into what the industry is doing. This has introduced some concepts. This has kind of let you know where we are heading. And more importantly, let you know where we are weak, right? Because opportunities come in areas of weakness. So if 2 things that I can say we are weak in, one, at least around us, the machine learning AI system is not very smart. We have these speakers, but out of experience, we know that they have some sort of entertainment value, but beyond a certain point, we don't tend to use them as much, right? Two, they've really not been created for our Indian languages or even Indian English. A lot of opportunity there. And there are still some very tough problems to solve, like we did in the thought experiment, which are very trivial to humans, right? So I think at this point, I'm going to stop. So I've taken about 35 minutes, I think. More than happy to give it back to Arun and Reggie sir, and open for any questions. If you want me to go back to some slides, repeat some parts, or explain some parts, more than happy to do that at this moment. Arun, Reggie, back to you.
Yeah, I think students, if you have any doubts or any clarifications, any silly doubts, please feel free to raise it to the resource person. So you can raise your hands if you want to talk to Dhruv directly, or you can post your questions also in the chat box, be it anything.
I'm going to try.
Is there anyone who has any doubts or any questions would like to ask the resource person? I think one student by Harshavardhan. Harsha, go ahead.
Hello, good afternoon, sir.
Afternoon.
Sir, I have one question that you are saying that maths is important. I want to know some basic concept that we can focus on maths. Like many concepts are in maths, like algebra, probability. So, what are the basic concept that we can focus, which can help in algorithms?
Probability. So if you think about it, classification is eventually a probability problem, right? It makes use of probability theorems to determine what the best modes are. When it comes to regression, the mathematics there is more around statistics, right? So both statistical concepts and probabilistic concepts, if you have a strong understanding of those two, then you can more easily understand the mathematics behind the algorithm. But having said that, there are far more other concepts like weighting and biases. Those need to be studied upon, right? And I'm hoping that this sort of mathematics becomes part of the syllabus. I'm not sure if it is or not, but if it is, then that's very good. But your probability and statistics, I would say.
Okay, there's one question in the chat box. What is the main difference between AI and ML?
So AI is a superset. AI includes everything, right? ML is a specialization inside AI. So, and there's another specialization inside that called DL, deep learning. Now, really, the intelligence happens at the ML level. So right now, when it comes to capability, we are with deep learning very smart at doing very single pointed things. With ML, we are a little bit smart at doing general things. And AI overall, in our personal experience, is not as smart. So AI is the big superset, ML is inside AI, and deep learning is inside ML, if that kind of makes sense.
Right, looks clear. And there is one question from Shashank is, what are job opportunities for freshers in AI?
So I think two things, right? One, as part of your engineering degree, if you can somehow in your project work do some good AI or ML, and I'll tell you the truth, the reality of today's market is that even amongst the experienced people, not a lot of people are doing AI ML, mostly because they're not able to do the mathematics. I'm pretty sure had I been a student, and because at that time mathematics was more well understood to me, I would have been able to do AI ML quite well then. So it's a truth of the world right now that if you're a student and because you're good at maths at that point, you get a head start compared to, I would say, a lot of other people in the industry when it comes to these things. And basically, if you can demonstrate that you've done something reasonable with AI ML, right? I would say that the chance that you get selected is far higher than the chance that, say, somebody experienced in this field has. That is really the reality. I hope that's answered the question. Or maybe I spoke a bit much. Hello? Anybody there?
Can you hear me?
I can hear you. I can hear you. Were you not
Yes.
able to hear me?
No, I'm fine. Like I just put a. There is one question from Richika that if I were to do an online course, which one better, AI or ML?
So like I explained, ML is inside AI, right? And really, as I mean, it's as the question, if I put simply, is you're asking, am I going to learn English or am I going to learn a Shakespeare play? Basically, both are English, right? And realistically, if you want to have a good sort of head start, then you need to know English, and if you're need a head start in English, then you need to know Shakespeare in English also. So similarly, you need to know AI, and you need to be a bit specialized in AI, right? You need to do ML also. AI is overarching. ML is a specialization. That's what we do in engineering, right? We do CS or ECE. After the second year, we get out of the general subjects into the specific subjects. So think of AI as a general subject in the first 2 years, and think of ML as your specific subjects in 3, 4.
So what you mean? What is your conclusion here? Is like you would prefer students to go for AI first, then specialize into ML.
Yeah, for sure. You don't need to go into deep learning because that's too much. You need to be like PhD level to do that. But yeah, AI first and ML. Yeah, you have to do it that way.
Okay. And there is one more question from Dhanush. Which language of coding is most important for AI or ML?
I have done.
Students, like if you want to interact, feel free to interact with the resource person. I'll put you on spotlight. You can directly talk to him and have an interaction. Questions are fine in chat box. You can also interact as well. Yes, Dhruv, over to you.
So I have used Python a lot. The world seems to have decided that Python is the way to go. I have also used R. In my experience, using Python has been more fun. But I can also tell you that in R, you can tune the mathematics. But in Python, you can't tune the math. Basically, in Python, you have the libraries pre-built. And once a library is pre-built, you can't do much with it. You can't tune it or you can't modify it. Whereas in R, because you can do core mathematics in R, you can tune stuff. All of these algorithms have weights and biases, at least a bias. So it's far easier to adjust biases in R than it is in Python. But start off with Python because that is more reasonable, and you will find a lot of literature in Python, especially. So Python is a good one to start with, I would say. R, if you're very interested, yeah, do R also.
Nice, that was clear. And there is one more person who would like to interact, Mr. Karthik, who was the former resource person of our second series. Like, looks like he wants to interact. Yes, sure. Karthik.
Hi, Dhruv.
Hi, Karthik. How are you?
Yeah, good man.
I'm trying to see the screen share one. Yeah, go on. Sorry.
I was waiting for some students to go on, but I'm the first one to start with the face. So for me, I have, with some years of experience, in some cases, I have heard this machine learning and artificial intelligence. Artificial intelligence is fine, but machine learning since the last 5-6 years. So in a layman language, I mean, to understand it as a fresh, I put my words and then please correct me if I'm wrong. I have a machine which is having a start and stop button. I switch it on and switch it off. It works in the way it should. It's a normal machine like drilling or punching, for example. If I have the machine to start and stop on its own, where it can, based on some parameters like the temperature is going off or the humidity is like this and so on, it's the next level. Do you call this machine learning?
No, so that is based around sensor data, right?
Mm-hmm.
So that goes back to my autopilot slide, if you remember. See, autopilot in airplane, you would imagine very complex, right? Aeroplane has hundreds of sensors. It has to fly a plane which has hundreds of people in it safely at reasonable altitude. And autopilots have been around from the 1980s, right, Karthik? And Boeing never called it AI. Airbus never called it AI. They just called it autopilot. In fact, I think the word AI itself was not coined there, right? And the reason for that is they never used any learning in that process. What they used there was, say, my temperature sensor outside the plane is telling me it is minus 30 degrees. And minus 30 degrees entered the main program. And there was some if-else logic there saying, if it is minus 30 degrees, then switch on the heating element in some part of the plane. Or if you're going this very fast, then you need to reduce. There was no, like, the machine was not learning there. The machine was making choices there, right? So when I got into the industry, my code, even now, my code is making choices. It's doing if, it's doing else, it's doing for loops, it's moving from here to there, but it's basically fundamentally making choices. It is not making a decision. It is making a decision after some choices, but it is not making a decision outright, right? That is where, I mean, it's important. That is where I would say is the difference where sensor data, neural networks and sensor data, which is where we are at right now. I think I'm not being succinct. Let's take an example. You have an image in front of you, and there are three faces, right? Like you take a picture in your smartphone. It's able to identify faces. That is intelligent because the faces can be anywhere. It's made use of neural networks, and it's found the faces, right? So that is sensor data plus something. So I think where we are at is at that plus mode. What are we doing additionally, right? Sensor data has been around for a very long time, and we've been able to use sensor data in sort of pseudo intelligence for unbelievable things. And people reach the moon with just sensor data, right? So short answer is no, I would not classify that as intelligence. For intelligence,
Understood.
At least some amount of computational neural networks or some sort of prediction has to happen.
Yeah. Last note. In Germany or in the European markets, as you might have seen, so the data that is used, I mean, from ERP point of view, we see this as I'm an ERP consultant. So I see this data which is being used, for example, like the weather conditions and the demand of people who are living in a town and their expenses or how they are spending features and so on. Use this kind of data, for example, and then supply the kind of goods that will definitely be sold in this area based on the weather, based on the currency spending and so on. Do you classify this as something related to here?
So first point, I have not actually tried to solve those sort of problems in my experience. So I've solved other sort of problems, right? So if your question was in that field, I would have been able to give you a very precise answer. So my answer is going to be a bit imprecise. And hopefully you appreciate the fact that because I've not been in that domain, it's going to be a bit...
That's completely fine. Everyone learns something.
Yeah, so at a high level, right, there's definitely more than normal intelligence there. I'm guessing that definitely teeters on some sort of AI for sure. Does it go into ML? Not so sure, because ML can be defined in very specific words like regressibility, detectability, probabilistic mathematics, right? So it gets kind
it always has to do something with the machine, isn't it? ML.
So I think in ML, machine is a misnomer, really, right? It should really be computer. It's not like a drilling machine or a car.
So this is something I heard from my earlier experiences where this really the machines are there, for example, the lathe and CFD or 3D printing and so on. these machines really have connected to the AI. And there are several apps here. And this is the other area of ML, which I have been hearing.
Yes, yes, yes. So that is more right. So I think machine learner became a misnomer very early on, right? Because I'm sure in the 1990s or early 2000, it was the world was far simpler, right?
I just switched from my mobile to desktop because of the power issues. So I think Principal Sir or Hari Krishna sir, like if you can pick some questions from the chat window and can ask it.
I'm done with the two, so I see some questions and others can go
I
on.
lost the chat history because of the switching over.
Yes, sir. Sir, there is one question from Priyadarshini. Is there any possibility that developing any sort of advancements or new technologies are possible by artificial intelligence itself without the help of developers?
Yeah, so that is the action step problem. Unfortunately, the answer to that right now is no. But the more important part of my answer was right now. Right now it is a no. But as you can imagine, scientists are working very hard all over the world. Google is working very hard. Facebook is working very hard. And maybe Google has something in that step that it is doing, but it is keeping it private. And it will most likely happen, I think, in the near future, right? But short answer is it is not available in academic literature right now to any degree that is usable to the real world. But everybody is putting a lot of money and a lot of resources behind this. So in the near future, it will most likely be the case. I'm sorry if that was a very long answer, but I think that is what the state of the world is right now.
And Dhruv, do you see any scope for the students to take up any projects in this area at the UG level?
Oh yeah, for sure. So like I explained earlier, that the reality of our world right now is that the experienced people can't do the mathematics. And I'm telling you this from experience because I hire people. So I'm going to be very careful in choosing my word right now. If you do your mathematics, I would love to know about you or say have you in the organization, because it's very difficult for me right now to find people with those skills. See, you would have spent, if in undergrad, at least a few months doing that. Right now, I can't find experienced people who spent months, let alone find people who've spent years. And if you do like a master's where you spent years on this, then that's amazing, right? You have a sort of a heads up to quite a bit of the IT space right now.
We got Ankit here. Ankit, go ahead, ask your question. Ankit Agarwal.
So I think I can read Ankit's question on the screen. Yes. So what is the process to be followed when implementing AI in an organization, right? So if that is the question, I'll answer it. See, AI is very expensive. And as far as big organizations are concerned, now I was part of NTT, and people might not know this, but NTT is a Fortune 50 company. So it's a very rich, very big organization, right? But even there, before implementing AI, and you will realize this in the real world, cost is everything, right? AI is very expensive. And as I said in my talk, AI needs mathematics that is mostly based around probabilities. Now, in the probabilistic world, if you do an AI implementation and the probability of your answer being right is 0.6, 0.7, while that might be considered to be really great academically, in the real world, if the probability of your answer being right is 0.5, 0.6, then that is not great, because if your answer is going to be 50% of the time right, then instead of having spent the millions of dollars setting this up, you could have just spent 10 minutes and written a coin toss program, and that would have given you 50% probability in and there, and that would have been a lot cheaper, right?
Yeah.
So AI and ML right now are being done academically more, but real world, if organizations want to do it, they obviously have to factor in large costs. and the resources needed to do this are not a lot. And that's why I'm saying, so it's a really big opportunity for students because there is a severe resource crunch at the moment, right? So costs are large. And so yeah, it's difficult. Organizations have to first pay out a lot of money because money is king. And organizations have to wait for a lot of time because it takes time to implement it. And organizations have to be able to accept that results are not going to be really good in the beginning. So there are a lot of challenges in implementing AI in an organization. I mean, you would have experienced speaking to an automated voice response system. There's nothing intelligent about it. It's pretty dumb, and you nearly always end up calling a call center or interacting with a human right now anyway. Yeah, so that's my long answer. I think I can only give long answers. Short answers are not forthcoming today.
Yeah,
Dhruv, there is one question in the chat, which is the technology destroying our Earth?
Oh, that is a
Your job is at stake now. Eh?
So that is partly political also, right? So AI takes a lot of resources. There's no doubt about that. You need a lot of machines. By machines, I mean computers. I don't mean drilling machines. Well, I mean drilling machines, because if you need to make computers, you need a lot of drilling machines to create those computers. You need a lot of natural resources to create those drilling resources. So yeah, it does have. I mean, it is very, very energy intensive. Believe me, it is very energy intensive. It takes a lot of computing capability. For example, heating problems are a real problem. So when we write code thinking that it can just run. But we nearly always get a call from the operations team saying, you wrote code, but you were idiots and it heated the entire data center up and now everything is down. They really speak to us in far more flowery language with a lot more other words that I cannot speak of right now, because heating is a problem. Heating is a real world problem, right? And heating, mechanical students will tell you, impacts everything. So yeah, long answer is it is a problem.
Okay, I think there are a lot of faculty present in the forum. Like, if you want to ask any questions, please feel to interact. It's not only for the students, like everyone, open invitation to all alumnus, external resources. Like anyone who would like to interact, please feel free to. So, can you share any of your challenging moments which you have combated successfully in this field?
I could very easily, but I would also be stepping into the non-disclosure world.
Yeah,
and I think I've used too many company names already. So I'm going to selectively say no.
Okay.
I'm sorry, but that's how the world is these days.
Okay, we have once again Harshavardhan here. Harsha, go ahead.
Hello, sir. Sir, I want to ask that now times when we run algorithms, many platforms are not efficient enough.
I'm sorry, the only thing I got was the platform is not efficient enough. I didn't get the question, I think.
Harsha, we are
I think
losing you.
audio cut off.
Your question is not. Can you repeat? Are you there?
When they're running algorithms,
So, can you tell me some algorithms without any lagging?
Okay, Harsha, I would recommend you can mute your video so that your bandwidth will get stabilized, so the interaction gets better. Just repeat the question once again.
Or you can put it in the chat. Maybe there we can pick it up.
Yeah, sure, sure. Sir.
In the meantime, the question comes up. I just want to share something about this maths topic, right? Which Dhruv stressed, work on your math, work on your math. So I was always a fan of math and the part of differentials and integration. Do you get to use this too, Dhruv? Differentials and integrations?
Oh yeah, you're going to find it. Sometimes you think that the scientists are just throwing it around for the sake of having fun with the person who's reading the document. Like, I have actually seen somebody throw around integration in a document, not because it was really needed in the algorithm, but because they were trying to act smart. But yeah, there will be some integration somewhere. At least in the screenshot that I showed, I think there was some differentiation there. Let me just go back to that, right?
There was a lot of sigmas. That's what
Yeah,
I remember. And differentials, yes.
yeah, so
Differentials,
there's
yes.
log. So obviously, when you have log, you will somehow get into integration differentiation also, right?
I need to refresh my math then. I've gone there.
The question is posted here: how we can choose a good platform for running ML algorithms? That's the question from Arsha.
AWS is a very good platform. It is one of the most mature platforms. AWS, and AWS gives you a free tier. So I think for the first year, you get quite a bit on the free tier. So you can create models. AWS right now, I think, is having its deep research challenge where they train you in. I'm still sharing my screen, right?
Yeah, you could see.
So, why is, I think Zoom interferes with the AWS deep research? So this is a good sort of platform to kind of learn your AWS, to learn machine learning, and it's free for, I think, a very long time where you can train models and all. They're doing reinforcement learning, and I know I mentioned in my slide reinforcement learning is not the best, and they're claiming that RL is advanced machine learning. I will disagree with them because I think they're trying to sell services more than that. But yeah, get on here. You can always explore here. It's free, and even when it's not free, it's not very costly. Only trick is getting your parents' credit card number, which they might or might not give you. But you can always try. I tried. I didn't succeed. Maybe for the better, I think.
Okay. Yesterday I asked a question like, can you throw some light on these courses, which I
yeah. So I think a question was also asked. So I understand that, and I'm sorry about this that I didn't include it in the slides. Must have completely skipped my mind. Obviously. So I see. Wait, I'm just opening up my WhatsApp. Hold on. I'm not going to open up WhatsApp when I'm sharing my screen because that would be a bad idea.
There's another question in the meantime. Is data science includes ML and AI? If yes, how?
Yeah. So data science, you have to be sort of data scientist to do ML properly. And you definitely need to be a data scientist to do deep learning, right? So what do data scientists use? Data scientists use R. They don't like Python because it's not cool enough for them. To give you an even more simple example, there is the C++ world, which is very complicated. Then there is the Java and the C# world, which is a bit more abstract. Now, a hardcore coder will code in C++, whereas a lazy coder will code in C#. But most programs are made in C# Java in the real world. So yeah, data science is R, and you have to be deep in data science to if you get into data science, you will know these algorithms like the back of your hand, for sure. So I'm just looking at the Coursera courses. So you have AI for medicine, you have AI for medical diagnosis. I think AI, you have AI for everyone. My thought is machine learning for business professionals. I'm just going through the images. Give me 1 minute. Oh, there is deep learning in Azure ML Studio. So I would say do the one which says machine learning for business.
On screen as well, like it's been shared.
Yeah. So can you go to the next one where you have machine learning for business professionals?
I think I'll repeat the question. This was like yesterday I requested Dhruv to go through the courses that were offered in Coursera, as most of us are enrolled in Coursera through the institution enterprise edition. So which are the right courses that the students can choose and go through? So I think is going to be on that.
So I think AI for everyone would definitely be the course that you should start with. And I can see here they have these concentric circles where I think they mean in this image that AI is outside, ML is inside, and deep learning is further inside. So I'm guessing that's what that means, but I could be completely wrong. Obviously do this first. Machine learning for business professionals would, I think, be an add-on from year to year, which maybe gives you a more reasonable progression. And then after this, I think one of your slides said AI in medical diagnosis. That seems very interesting. And that would definitely be very close to the real world, right? That would give you a real world sort of problem and a real world solution. And the real world will really appreciate the fact that you're aware of the real world. So yeah, so I think go in that progression. AI for everyone, AI for business, and then AI for medical diagnosis. I think that would be the right way to take this.
Nice. So these are the three courses that picks from you, right?
Right.
Okay. And there is one question from Professor Harish that which programming language is better for any mechanical students to learn AI in a better way?
So
What is the scope of AI for mechanical engineers? You can start off from there.
So even before answering that, I think mechanical engineers have the advantage that they do a lot of deep mathematics. I mean, if I compare, there used to be two subjects, strength of materials and something else. They were really feared subjects, right? Because one, they were complex and it was very difficult to pass. And if I remember correctly, and maybe my memory is failing, there's a lot of mathematics there that was needed. And if I compare that to the CS world or the ECE world, not that much mathematics and not as complicated by any means. So mechanical students there, I think, have an advantage because their syllabus, at least around that time, was quite deep with maths anyway. Now, when it comes to languages, I think Python is the one you want to start with. One, because Python is a bit easier to understand than R. And two, you want to start off with examples that interest you. Python can give you a lot of real world examples that will interest you. Like, for example, this AWS deep racer that I was talking about assumes that your deep racer is a robot which has two cameras on it, and the camera provides you values, and that is that sort of initial assumption and initial setup is quite in the mechanical world, right? And then you consume it down into the AI world in Python. So I think it is quite natural. I'm in my personal opinion, between mechanical and computer science, right? I think AI ML is a bit more natural to the mechanical world than it is to CS and EC. So yeah, do Python and do these deep learner sort of things. Once you do these, you will realize that they rely very heavily on mechanical concepts: speed, momentum, torque, heat.
Nice. So anybody else, any other questions, any interactions awaited? If no, then we will move on to the next segment. So if there is any, please raise your hand till the completion, right? So that was one nice interaction, Dhruv. It was a fantastic time. So we got to know a lot of information. I enjoyed the interaction part much. You know, a lot of nice, interesting questions came up and good answers, good informative information the students have received. So hopefully we will stay connected. So wherever there is requirement, wherever there is need, we will try to connect the students with you. You can guide them as well, remotely from there. And my invitation to you, whenever you visit Bangalore, please do come back to campus and you can say hi and you can share a meal with us, right?
Mm-hmm.
And I think a lot of students participated in this session. So thanks to all the students. So thanks to Dhruv. And Karthik, thank you so much for joining us again. And there are a many people who are directly or indirectly being a part of this event. So the interaction was very nice, and thank you, because Dhruv, as I heard from him, nowadays work from home is becoming very hectic for all the IT people, and holidays are like a big thing for people working from home. So one such holiday Dhruv has dedicated for us, because the session may lasted for only 1.5 hours, but the preparation and the effort what he has put, the demo session, the rehearse what we made, he had spent quite a lot of time for bringing this program out in a successful way. So thank you, Dhruv, and thanks to the technical team for engaging and for making all the work. So I would like to request Hari Krishna, sir, the Secretary of Alumni Association, to formally end this program with a vote of thanks.
Yes, sir. It's indeed a privilege and great joy for me to extend the vote of thanks for this Senior Talk program on behalf of Saram family. At the outset, I would like to express my deep sense of gratitude to our founder chairman, Sri MJF Lion Leomuthu, who is responsible for us to be here. I extend my sincere thanks to our CEO and chairman, Sri Sai Prakash Leomuthu, who has been a constant source of inspiration for all students and faculty. It's great delight and privilege to thank today's guest, Mr. Dhruv Chopra, for sharing his knowledge to his juniors and giving insights on AI, ML, and data science. Thank you, Dhruv. Thank you so much. I thank Karthik, Nirmala, and many alumni who are part of today's senior talk program. Thank you all. I thank our beloved principal, Dr. B. Shadakshappa, who was instrumental in organizing this knowledge sharing continual learning senior talks program. Thank you, sir. I express my sincere thanks to our management representative, Dr. R. Arun Kumar, for his continuous support and encouragement. Thank you, sir. My heartfelt thanks to our trustee, Sri Patel, our Chief Accounts Officer, Sri Gajendra, sir. Thank you, sir. I thank heads of departments for motivating students to attend the Senior Talks program and making it success. Thank you all. I thank our Alumni Association coordinators, Harish Babu, Mr. Aruna, Mrs. Aruna, Saujanya, and Mr. Prashant for their continual support. I thank Mr. Raji sir for technical support. My heartfelt thanks to all students, participants who made the day. Thank you all. Thanks, sir.
Thanks to Girish as well, who's been the connect to bring in Chopra.
Yeah, founder secretary of Alumni Association. Yes, sir.
He is the one who established the contact. So, Dhruv, any final words or any takeaways from you?
Just enjoy yourself and work hard. I think that's all that everybody says anyway. But enjoy yourself. I mean, if you don't enjoy yourself, then it's not worth doing it, I think.
Thank you, Dhruv.
Thanks.
It was a wonderful and a very informative session. Thank you on behalf of everybody.
All right. Thank you.
Thank you.
Bye-bye.
Thank you, Dhruv. Thank you, Karthik.